All right. So a couple people said the last couple of problems, I imagine.
Like I got like all the like the work right, but I didn't know if I got the shading right.
All right, let's talk about it.
I think I was confused. I was confused on number 4.
Okay.
No, it's the wrong homework. That's the wrong homework.
So I'm going to do number 7. I'm
I
going to
don't
do
know. Can you do 13?
Number 11. Number 11.
13. No, 11 was
11.
the easiest one. 13,
11
13,
I knew.
13, 13, 13, 13.
13 I
Oh,
got.
I'm
11 I didn't
gonna,
know.
I didn't understand the or ones.
okay.
Or
So I'm
it's
going to
easier
do
than
one and one or, okay?
Okay, so do
So-
do
Do
11.
13,
17.
13, 13. And
And I'm
13,
going
and
to do
13.
13.
11. 11.
Thank you. 11 was the
11.
easiest one of the homework.
Well, how do you do
divide
it?
right.
How? Tell me. How?
Okay, fine. I'll do it for you right now.
Do it right now. Go.
Okay.
Screen share and do it.
Can you give me here? Okay,
No,
what's the
no.
question?
You can go on Zoom, open your own Zoom, teach them if you want. Oh, are you? No, I don't see my thing.
Wow.
It makes no sense. How do you? What do you do after you get the negative 1 is less than or equal to 4m less than or equal to 16? What do you do now?
Less than 8 or
Look.
-8.
Okay.
Okay.
Like,
Hey,
your handwriting, it's so bad.
He's doing it on his finger or something. And then
Yeah, I was about to ask if that was a 7 or an
That's
X
correct,
because I'm
Henry.
very confused.
Your handwriting is beautiful.
4m over there, and then it's is that a negative 4m? I can't tell.
What's the first number?
Is that a
One.
7?
Is it a negative 1?
Yeah.
What a
4m. 16. Okay.
Do it.
So
Mr. October, can you please do it?
pretty simple. It's pretty simple.
Shakeman, he already did it for you. Look, you split it into 2 equations and do it.
And then all you
I'm
have to
going
do
to
is
do number
divide by
17.
4.
and
All you do is
both
divide
sides
by 4 and you have your answer.
Negative
Huh?
4, by the way, so you got to flip the sign.
So it's equal -1 less than -4.
Yeah, I'm erasing. I gotta do mines, okay?
No. 2 seconds. 2 seconds.
You still divide by negative 4, bud.
All right.
Oh, so you put it into two equations.
Yes.
So
All
then
right.
you get.
Oh boy.
Then
Now
you
I gotta
Wait,
go and
Wait,
disable
wait.
annotations.
No. So then you get
Jesus.
m is less than or equal to. M is less than or equal to 4.
Mhm.
Then m is greater than or equal to 1.
1 divided by negative 4 isn't 1.
Oh, so it's 4. I think.
It's 1/4.
Isn't that 0.25?
It's not
This
4.
is number 17.
Then what is it?
Isn't
1/4
it
or
0.25?
0.25.
Oh.
0.25, yes.
So
All right.
0.5.
So pay attention to this one, number
Wait,
17 on the.
So m is less than negative.
So v plus
What's
13
that?
is
Wait,
less than
wait.
8.
Why do you
What's
mute
that
me?
thing
Why do you
after
mute
the
me?
V?
I'm up to the air. I don't even know anymore.
Is that a V after the -8 on the right?
Yeah, they're both v's.
Okay.
And the question is v. If you wrote an x, that's okay.
So you get m is greater than or equal to 0.25 and m is less than or equal to 4.
That's probably true. Check the answers in the back.
Yeah, I
So-
did. They didn't have the answers for this.
How? It's odd.
So photo math it.
So, first one, v plus 13 is less than 8. So I do it. V is less than -5 because I subtract 13 on both sides. Remember, I only flip the sign when it's a divide or multiply by negative,
17.
which over here occurs. I'm going to divide it by -8. I'm going to divide by -8. I get v is less than +5. But,
That's the v is greater than 5.
excellent. So v has to be switched, or the inequality has to be switched. So v is greater than 5.
Mr. Tobe, I have a very important question.
Hold it. And then -5 over here and 5 over here. So you want to do each one separately, and particularly to Rachel's question, how to graph it. So v is less than -5. So I have an open circle, and v is smaller than -5. So I go to the left. And then v is greater than 5. So I got an open circle.
Hey, I still don't get the shading. I did the shading wrong.
Okay. V, or
Okay.
whatever
If
variable
it's
it is.
less than, it goes to the left, and if it's greater than, it goes to the right.
You know what? That's true. Yeah.
Cheating.
Because it's v less than -5. So Rachel, you're thinking numbers that are smaller than -5, -6, -7. So that goes to the left.
Oh, so then for the other one, it'll go the other side?
Yes.
Oh, that's so
They're
easy.
two separate things going on. Yeah. Okay.
And then how do you know if it goes the other way? Because you like said it was like confusing yesterday.
Sometimes they go into each other if it's an and statement, which I'm about to do for number 13.
But
Okay?
never if it's an or sign.
Or I'm going to go over special cases in case that happens, and I'll talk about that. Okay.
But or it's usually not.
Usually not. No.
For number 13, is one of the numbers like a weird fraction?
We'll see. 5, 3. Let me do it, and then I can answer. that
Negative
question.
1 and 1/4.
Notice that it's one big term. When it's one big term, you know it has to be a thingy, an and statement. Hello? So number 13 from the homework. I'm going to split it to two separate equations. Please don't forget, when you split it, you have to use the middle the whole way. Don't split the middle. You're making a copy of the middle for both of them. So negative 15, the less than or equal to 5, parentheses, 3p minus 2. And 5, 3p minus 2.
I did this so
Is
wrong.
less than
I just
20.
distributed. I don't know.
Don't you
Well,
I
we
did
haven't
the
done it.
shading.
Yeah, me too. I distributed.
Yeah.
So
to multiply?
you could do two things. You could divide by 5 first, or you could distribute a 5. So it seems like most of you guys distribute. I'm going to distribute. I'm going to take the 5, distribute here. Take
So
the
then
5.
again, negative 15 is
Oh,
less than 15.
Let me just be clear. You should split it first before you do any math. Now, you would not be wrong if you distribute first, then split, but you want to split it first before you do any math, just in case, because you don't want to make a mistake. So negative 15 is less than or equal to 15p minus 10. I got a plus 10 on both sides. Negative 5 is less than or equal to 15p. I'm going to divide it by 15. Not TS, but 15. That's going to be negative 1/3 after I simplify it is less than or equal to p. That's one part of my answer. Second part of my answer, I got to do the right side. Again, distribute. 15p is minus 10, which is less than 20. Plus 10 on both sides. 15p is less than 30. Then divided by 15 on both sides. P is less than 2.
I got this completely wrong.
All right, so fix it up.
I
Or-
got the
You graph that?
but I got the first part wrong.
So let's graph that. Negative 1/3 is definitely smaller than 2.
Would negative 1 and 1/4 be fine? Or no?
Negative 1 and 1/4. That's not the same number. No.
Wait, Mr. Toll, I just combined them, so I got negative 1/3 is less than or equal to p, which is less than 2.
You could do that too. That's fine. Because you could rewrite it as what who said that? I wasn't looking at
Me.
the camera. But what he said, we could combine it into one term. Negative 1/3 is less than or equal to p, which is less than 2.
Oh, I just graphed wrong. I got all the
Could
right.
could I show you how I graphed it?
Well, let me talk about it, and then you could tell me how we're different.
When I
So I
did-
put a solid circle, and I know it's p is greater than 1/3. So p
Mr.
or
Bobo?
1/3 is less than p, so p has to be bigger. So I'm going to the right in this case.
Wait, Mr.
Now,
Tobo?
I don't go the whole way. And the reason I don't go the whole way is because I have to keep in mind the 2 over here. I have an open circle at 2, and p is smaller than 2, so I go towards this way. You notice they're going to run into each other. Because
Mr. Tobo?
it's going to stay within that range. Now, you could ask your question who's saying
Uh,
when I did it for
Go the girl first. Hello?
Mr. Tobo,
Yes, go ahead.
do you have to like put the full problem? Like, I answered the question and I did like the graphing part, but I didn't put like -1/3 is greater or equal to p, which is less than 2. I didn't like do that part. Just like
No, you're good enough with this, and the graph. You don't need that part, but somebody mentioned it, so I just rewrote it like that. Some people find this easier to graph because it's like obvious. It's going to P is in between -1/3 and 2. Okay. Anyone else with questions on this?
Yeah.
Go ahead.
When I did that myself, like without, I didn't. Wait, I can't think right now. I didn't distribute like both of them. I just distributed like first, and I got it that P was less than or equal to -1/3. I don't know how.
I got
P-
everything right except for I also distributed in
Like I got everything. I got,
I got
all
the
the math
same
right.
exact I got
just
the
got-
same exact
I
graph.
just got the sign wrong. Like
Did
the-
you write it in this order? -15 is less than blah.
No, because I did it right off the question. Like I did -15 is less than or greater to or equal to.
That's why you don't want to do it off the question. Rewrite it as 2 separate questions, because that kind of mistake does occur if you write it off the question, because then you're moving P around or something like that, and you get awkward. So separate it first and then do it, and you'll avoid that kind of issue. Shank, you said you got what, 1 1/4? You said.
-1 1/4. I distributed in the beginning.
Yeah. Did you get 15P minus 10?
I just erased anything, but I think
So you probably forgot to distribute to the 2 or something. It's going to be my guess of how you got that answer.
I got
but
the P is less than 2 correct and the graphing right, but I didn't get the first number.
Then I'm not sure because I can't see an easy way to get 1/4. Unless you, no, I don't know. Because if you got 2 right, then you must have did the other side right. So that's why I'm confused. I don't know. Any other questions on these? The and or statements?
Yeah. Can you distribute first, or do you have to split first?
I would split first before doing anything, just to avoid problems.
Why though?
You could distribute first, and then you could have 15P minus 10 and then split it. There's no, that's like, it's the same way, like I always move the smaller X. It's just my way to do it. You don't have to do it like that, but it's a suggested at least.
Mr. Toll, I actually have a question.
Yeah.
So for the rule of like how you would graph it and stuff like that,
Mm-hmm.
and let's see how the formula on the bottom you did the -1/3 is greater than or equal to
Less than or
sorry,
equal
it's
to
less than
P,
or equal
less
to
than 2.
P. Yeah, that one. So for that one, can you just like take the 2 numbers you got that were like
Yeah, you do not need to write this if that's what you're asking. You
no
don't
no
need to write
no I feel like that way is like easier for me to understand.
Uh-huh.
But like what I'm asking is that let's say can you just take the 2 numbers and then just take the signs from the originating equation and then just plug it in?
Like from here.
Yeah, exactly.
You don't want to do that exactly, because what if you divide it by a negative or multiply by a negative?
Mhm.
Then this would be flipped. So you want to be careful when you do something like that.
Okay, got
It's
it.
a very dangerous game to play.
Yeah, makes
So
sense.
I wouldn't do that. Mhm. Any other questions on this? Okay. Let's go to the last part of this section, and then we'll probably start the next section. Special case inequalities. Now, I call these special cases. If you remember special cases from before, there was 2 options. All reals and no solution. Okay. So that's what I mean by special cases, all reals and no solution. So you don't usually get a nice number line nor a good value. So first one, we're going to do all reals, okay? When I say all reals, all real numbers.
My computer died, sorry.
That's no sweat. So all real numbers right here. Oh, Ethan, I posted the YouTube video of the last lesson. Did you get that?
Yeah, I
From the-
watched.
Okay, just want to make sure. So here's a all real situation. Let me think about it. 2x is greater than 10, or let's do 3x is less than 21. Yeah. Or I should say, yeah, that's fine. So if you remember from the last lesson, an or statement is either one or the other. As long as one piece is true, then that number is a solution. So let's solve for each. For here, I would divide by 2, divide by 2.
As it goes like into each other. So how is that?
You already see what's going to happen. Good. So let me talk about that in detail.
What does it say on top? It says all real solutions.
Yeah, I just said all reals, but the full term is all real solutions. And I think I saw your answer, Yael. I agree. Divided by 3. Divided by 3. X is less than 7. So let's graph that in a number line.
It's a
And
really weird
as-
graph.
And someone has mentioned there's something weird with this. Well, here, X is bigger than 7. So I put an open circle. And this is an or statement, so I'm going to go. But wait a second. X is less than 7 over here. But because this is an or statement, I keep going and going. And then over here, I'm going to keep going and going. So why is that occurring? Let me talk about why is that occurring.
Wait, I'm so confused. What happened though? Like what you do? What did you do?
Good. What did I do? That's a good question.
Like I know like how you like did the full number line,
Mhm.
but like how did
Why
you,
did it color that way is your question?
yeah.
Okay.
Oh, the X is less than 7, so then but
Let me
if
talk.
X is less than 7, wouldn't it go the other way?
Wait, can or like statements never meet in the middle? They always have to meet the opposite direction. Otherwise, it's.
Oh, this is an
It's-
or statement.
Yeah.
I'm confused because like I see my like on the homework that they were both going the opposite direction. So this is
Uh-huh.
the first time when it's going the same way. So it has to always cross when it is.
So if they're going the same way, now let me explain, and let me do this by this way. I'm going to plug in here. What's a number smaller than 5? 4, let's say. Here's a 6, and let's put an 8. We're going to test all 3 sections to see if it's true in the original equation over here, okay? Now, it is a or statement. So because it is an or statement, that means one of them only has to be true. In an and statement, they both have to be true. So I'm plugging in 4 into this equation. 2 times 4 is 8. Is 8 greater than 10? Not in this case. 3, that's a weird looking 3, times 4.
Wait, why are you
Less-
plugging things in?
Because I'm going
Wait, what's
to,
happening?
I'm showing you what is occurring. 12 is less than 21. Excuse me.
That's true. That's true.
That's true. Because that's true, that indicates that there's an answer over here in this
Wait,
red
but
space.
5 wouldn't work. If you plugged in 5, it wouldn't work.
It wouldn't work for this one,
Oh,
right?
yeah,
The-
yeah.
Wait, why
But
are
it
you
would
plugging
work.
in number?
Yeah.
I'm so confused. Like, what? After you did the problem, like, I'm so confused. Like, why you're plugging in numbers and whatever, and like how it's like all real solution.
Sally, I'm trying to explain why.
He's doing it to prove which one's real or not, like to see.
Mm-hmm.
What happens if
So-
you plug in 6 or 8? Same thing.
If you plug in 6, that would work for either one of these. And you've plugged in
Wait.
8, it would work on this one over here. So
Wait,
why am I
but
plugging
why
it in?
did you before like do a whole like what did you do with the line before?
Yeah. So what is occurring here, guys, is that if 5 is greater than, x is greater than 5, I put an open circle, and it's an or statement. So nothing limits me. I just go on forever. Okay? Because a billion is still greater than 5, 8 is greater than 5, 6 is greater than 5, 7 is greater than 5. So I just keep going forever. But what's also occurring, and I'll do that in green to show separate, at 7, I have answers less than 7. So 6 works, 5 works, 4 works, so forth, so forth. Which means this whole zone right here, or not just this whole zone, every real number that exists is an answer. I can plug in any number that is real into either this equation or that equation that causes it to be all real solutions. Or we have a symbol like this.
Wait, could you like, so anything less than 7 would be all real solutions for 3x is less than 21?
If you're thinking about it in graphing, yeah, oh, that's true, yes.
And
This
then,
is the same thing, yeah.
or anything greater than 2, anything greater than 5 is all real solutions?
No,
Also?
the reason it's all real solutions, it's an or statement.
Isn't it all real solutions because it can go, it's like right either way you go?
Exactly. But I'm talking about in a graphical sense. Like, why is it occurring in the or statement here? Because this or statement that goes towards each other. So like normally our or statements used to go separate directions, right? Because they go towards each other, they run over each other and cover up the whole number line. So an or statement that goes towards each other is all real solutions.
So why isn't it considered an and solution if they go towards each other?
Because I said in the beginning, it's an or statement.
So every time, so let's say like on a test, like let's say like we see that like it goes together. Can we just say all real solutions? Like do we have to like?
Yeah, you just say all real solutions.
Okay, fine.
As soon as you notice it's all real solutions, tell me all real solutions. So notice how that's awkward. When an or statement goes together, it causes a all real solution. Can anyone guess what's going to be a no solution?
And they don't go together.
When they go opposites, like one goes one side. One goes
What goes opposite?
When one goes to the one
They,
side.
like,
and
don't
one-
cross
yeah,
over
one goes to the
each
left,
other?
and one goes to the right.
In what type of statement, though?
And
An or statement, and statement, or.
Oh,
And-
when they both go the same
And,
way.
and statements when they both go in the same direction.
Yeah, when they both go in the same direction.
Like
Oh,
they both go to the right or they both go to the left. So it'd be like no solutions for and.
There's a lot of theories, but the answer to this situation, a no solution, is going to be when an and statement goes opposite
I
direction.
said that.
Wait, so all real solutions.
Craig, I said that first and then you said that.
No.
It's not
said or
competition. I was
statement.
just testing your brains. Somebody was making a question now. Go ahead.
Mr. Tolbo.
Yes.
So or solution, I mean all real solution is only when or, like when you give us an or problem
That goes.
that goes together, and then the no solution is when like the and one goes in opposite directions. Okay.
Good. And I want to explain the reasoning because of that. Because I just,
can you
I
scroll
just,
up like a little bit so I can get the? No,
oh,
never mind.
yeah, sure. Like that? You got that?
Like just a tiny bit more.
Like this? Wait, like this?
Yeah, that's good.
Okay.
Thank you.
So let me explain why that is, though. I said an or statement, it's one or the other. An and statement, both have to be true at the same time. So instead of making it a problem, I'm just going to give you a really simple one. X is greater than 5, and X is smaller than 2. Let's look at that for a second. If I ask you, what is a possible answer for X? Which I'm basically asking, is there a number that's both bigger than 5 and smaller than 2? Now, is there any number that's both bigger than 5 and smaller than 2 at the same time?
No, so there's no solutions.
No, that's right. There's no way you could be bigger than 5 and smaller than 2 at the same time.
So for this thing, how do you graph it?
You can't graph it.
So you just write after you like get the answer, whatever, you just write no solutions.
Well, I'll tell you this. You probably don't know it's a no solution, let's say, while you're doing the work, right? Let's say you're on a test, right? And you're just doing the problem. You know it's an and statement. You start graphing this. So you have X is greater than 5. So you have an open circle here. You start coloring this way. And then X is less than 2. You have an open circle here. It's less than this way. At that moment, you should notice something. Wait a second. This is an and statement, and they're going opposite directions. Uh-oh. So that must mean it can't be 2 and it can't be smaller than 2 and bigger than 5 at the same time. So that's a no solution. I'm thinking as if you were doing the problem as you found it out, because here it's pretty obvious. Like I'm saying it also. X, it cannot be bigger than 5 and smaller than 2.
So when
Like,
the
you know,
line
you
goes through the whole thing, it's all real solutions.
If it covers the whole thing, it's all real solutions. If it doesn't cover anything, it's no real solution. Or no solution. Well, yeah, no real solutions like that. Okay. Okay, anyone has any questions on this? Or should I give a minute to write this down if people still haven't finished? All right, I'm going to the next page.
I'm joining back on my computer because I charged it.
Cool, no problem. Absolute value equations. Absolute value equation. This is section 5.5.
How many sections are we learning this year?
This section, you mean? This chapter?
No, like this year.
This year?
Yeah, like to what number?
We should get up to chapter 12, I think.
So what if we finish early?
Then I have more stuff. I always have more stuff. So
Do we have a midterm?
So far it seems like a midterm. I haven't heard any news otherwise. If you have any
Really
news,
hope we don't.
Are
I-
you giving us a problem, or is this like something new?
something new. This is the beginning of the next section, and then we'll do problems.
Wait, could you give us like a problem to try in the last one? Like,
We don't need to try that, bro.
The reason I'm not going to give a problem, it's more like a fact kind of thing versus a solve kind of thing. The problems that you do normally, like from the yesterday's homework, is problems of that type. It's just more like a factoid kind of thing, like a result. So the reason I'm not giving practice problems is it's not something that really is a practice problem-y thing. It's like it's just an extra type of situation. That didn't sound very mathematical, but I'm trying to describe it as best I can. So 5.5 absolute value equations. And you guys make a number line. These little ugly, but it's okay. Let's put -3, -2. Oh my God. -3, -2, -1, 0, 1, 2, 3. So let's make a number line for me. Okay. When I say an absolute value, that is, by definition, the distance between, or not distance between, the distance
Tobo,
from 0.
Mr. Tobo,
That's okay, Gabby, go ahead.
what happened?
No, who's asking? Who's talking?
It's Gabby.
Yeah, Gabby, it's okay.
All right, can you record the lesson?
It's already being recorded, no problem.
Okay, thank you.
All right, so absolute value, the distance from 0. Okay, so what does that mean mathematically? Well, let's say I want to find the absolute value of 3. By the way, when I ask for the absolute value, it looks like these kind of symbols.
Mr. Tobel.
Yeah.
So isn't it? I remember like teaching, like learning this last year. So like for 3 would be it would be 3, and but for -3 would be +3. Like,
Could you
Good.
just let him explain it?
yeah, right. So,
Negative would be like outside the lines.
Yeah, but hold up. Let me just explain why. But the good thing you kind of remember it. So when I say the distance from 0, you can't have a negative distance. There's no such thing as a negative distance. You can walk backwards 2 feet, but you can't walk -2 feet. Like you walk 2 feet backwards, but you don't walk -2 feet. And here, the distance between 0 and 3 is 3. So very straightforward. When you have a positive number, like in this case, absolute value of 3 will give me 3. But let's say -3 in this situation.
it would be +3.
The distance between -3 and 0 is 3. Even though you're 3 backwards in terms of placement, the physical distance between it is 3, so it's going to be 3. So while the definition is the distance from 0, what mathematically the absolute value of x is going to be positive x. It's always going to make whatever number's on the inside positive. Now,
We used like in like 6th grade for like, and then we learned it in like 7th grade also. Like
We learned it in Miss
Okay.
Bean Fox class for like half the year.
no,
but guys, you know the fact of what absolute value is. But what we're going to talk about is how we do it in actual algebraic equations, which I would be surprised if you did it. If you did it, cool. But so when I say something like this, what is the absolute value of x? That would give me 7.
7.
So somebody gave me one answer.
Negative
7 could be plugged in here. What else could be plugged in here?
-7.
-7. So my answer for x is going to equal both positive and -7. Because it could be +7 or -7. So x is both positive and -7. It could be one or the other. You technically have 2 solutions. You could also write it as simply 7, -7. That's okay also.
So does it say x is equals plus minus 7?
Yeah, so that's a quicker way to write positive and negative 7, but it's okay to write it as two separate questions, two separate numbers. It is two separate numbers. It could be 7 and it could be negative 7. So now we're going to mix it up a little bit. Absolute value of x plus 1 equals 7.
6.
6.
6.
So a lot of you guys got 6, which is good, because if I did x plus 1 has to equal, we already established has to equal a positive 7. So subtract 1, x equals 6.
Would it be -7 for the second one? Because
No,
-7 plus 1 is -6. Oh, no,
no,
wait, never mind.
no.
Or -8.
The second one, we just said it has to equal 7 over here. It has to equal 7 because you want the inside to equal positive 7. But just as we talked about before, it's not just positive 7 we have to set it equal to. We have to set it equal to -7. So we're going to do the equation. What's inside the absolute value? X plus 1 equals -7. And as somebody mentioned, you subtract 1 on both sides. X is going to be -8. So what does this mean? This means in this X, for this question, X could be a positive 6 or a -8. So you have two answers there,
Can't
6
you-
and -8.
But like,
Sure,
could
what's your
you
question?
use like mental math instead of like solving it like that?
So the reason I made it simple is to get the concept. Of course, the questions will essentially get harder where mental math is not reasonable in that situation. But yes, in this one, you could have done mental math. So this, no problem. So the steps, if I were to make this into steps, is 1, set, well, I would say isolate the absolute value. Now, in this case, the absolute value is isolated already. But step 2, set it equal to both positive and negative. In the question above, we set it equal to positive 7 and -7. The absolute value right here was already by itself, so we didn't really have to do for absolute. We didn't have to do question part 1, but set it equal to both positive and negative. And then we could just say step 3 is to solve. Each, I should say. Solve each. So you isolate the absolute value, you split it into a positive version and a negative version. And we're going to solve for both the positive and the negative version. Now, I would love to do practice problems on this, but we're running short on time. So copy down these notes. Your homework for tonight is going to be based off today's first part of the lesson with the special cases, with more practice on the compounds, because I need you to practice those compound inequalities. So you're going to get more practice with the compound inequalities. It might be a worksheet as a textbook page. I'll post it after I close the Zoom here. Okay?
Thank you.
Please copy down these notes. And once you do, type here in the chat for attendance, and then have a wonderful day afterwards.
Thank you.
No problem. No problem.
Thank you.
Hey, no biggie.